Welcome back, folks, to another session. Now, this one should be interesting because in the Kubernetes environment, it is easy to get logs from pods when they're available in the standard output. When the situation is different, though, things tend to get a little bit chaotic. So, to help you through that chaos, I've got Katarzyna Kujawa. I hope was that close? I'm
Yeah,
trying.
you are close. I'm Katarzyna Kujawa.
There we go. She says it so much better, and she'll say many more things better than me. As she's going to run you through tail your logs with tailing sidecar operators. Take it away.
Okay, hello everyone. So I'd like to tell you today how to tail logs using tailing Sidecar operator, which can help you in getting logs from pods in Kubernetes cluster when logs are not available on standard output. In this presentation, I will show you also why it's important to have logs on standard output and how to deal with the situation when logs are not available in standard output, also without tailing Sidecar operator. But I think that after this presentation, you would like to use this operator and you would forget about using different methods for getting logs from pods when logs are not available on standard output. So probably all people who know Kubernetes also know how to get logs from pods. There is no magic. There is one simple command to get logs from pods, and it is well-known command kubectl logs. And to be more precise, this command gets logs from the container, which are available on standard output of this container, and prints these logs to the terminal. And logs that you can get using kubectl logs command are also available in two localization on the host, just in files. You can find these logs either in varrock containers directory or in varrock pods directory. And you can see the structure of logs in these directories, how they are saved in this directory. You can notice that structure is slightly different for these directories, but both forms use namespace, pod name, and container name. What is important when you get logs using kubectl logs command, then kubelet handles this request and read logs just from these files available on the host. And I mentioned the fact that logs are also available on the host because this is very important because this is used by tools that can be used to collect logs from all pods in Kubernetes cluster and store them in one place. One example of such tool is FluentBit, which is commonly used in Kubernetes environment. And FluentBit can be deployed by Helm chart. On this Helm chart, you can see part of the configuration for this Helm chart. And on the left, you can notice that in input section, there is path set to var log containers directory. So FluentBit will read logs from this directory. And this is possible because FluentBit is commonly deployed as daemon set in the cluster. So there is on each node, there's one instance of FluentBit running. And it is possible because directory with logs is mounted to the pod in which FluentBit is running. So as I said earlier, the feature that logs are available on the host is used by FluentBit, and this is only possible because logs are available on standard output. Okay, and moving further, logs should be available on standard output, and it's not only the convenience, but it's part of the standard. We can find in 12 factor F methodology, which is methodology for building software as a service application, that having logs on standard output is important, and there is dedicated section about logs, and we can find in the section that that each running process must write its event stream and buffer to standard output. So it means that containerized applications should rely 100% on standard output. So it's not only the convenience that we should have logs on standard output, but it also methodology and best practice that we should follow. Um, but this is the theory that we should have standard logs on. We should have logs on standard output, but in the real world, the situation is different. We can find many examples of applications that save logs in files. For example, MySQL database save logs in many different files. It is done for many reasons, and we must just deal with such situations. And I will show you some tricks how to get logs that are not available on standard output. And I will start from the worst ideas to really good ideas. So, so we can start by examples. And I prepared this example uh, pod which generates in loop logs and save them just to the file. Uh, so it is very simple pod. And when you try get get logs from this example pod using standard kubectl logs command, you will see empty terminal. And I must say that this situation is quite dangerous because when something happens in Kubernetes cluster, then Kubernetes administrator will try to get logs using this simple command and, and we'll see empty terminal. So in critical situation, access to logs is very important and should be simple, but but here in this case, it is not simple situation. So I prepared the first trick. So we can run just in the container tail command to tail logs just in the container using kubectl exec command. And as you can see, it is possible to get logs using this command and have access to them. But of course, this trick has a huge limitation. It is only possible when we have access to shell in the container, and frequently we don't have access to the shell. For example, for distroless images, this trick doesn't work. Moreover, in emergency situation, nobody remembers about the fact that logs are saved in a specific file. So it's easier and safer when we have logs on standard output. Okay, so I prepared the second trick. It bases on adding empty dir volume to the pod. And this trick makes that logs are available on the host. So in the green rectangle, you can see the modification that I added to the example pod. And as I said earlier, okay, and as I said earlier, logs will be available on host in the place where empty dir volume is saved on the node. And typical localization of empty dir is mentioned on the slide, but I used to prepare this example microcades, and as you can see, the localization of empty dir is different. So this trick is not bad, not nice, but it requires some knowledge about empty dir, and you need to search for this log file on the disk. And if you want to collect logs from this pod using, for example, Flatbit, you will need to modify path to the log file in the configuration just to collect this specific log. So it is not the trick that I want to encourage everybody to use it. So we can move to the better tricks. And the good thing is that we are closer and closer to better tricks. In previous trick, empty dir volume joins application container with the host. Here you can see the trick in which two containers are joined by the volume, and the log file is saved on the volume. And because of this fact that log file is saved on the volume. Uh, this log file can be read by tail, which is running in Sidecar container. So Sidecar container must be added to the pod. And because of the fact that tail reads log file in the container, logs are available on standard output and also are available in standard localization. So for example, logs are available in var containers directory. So we can read these logs using standard logging pipeline for getting logs. So to use this trick, you need to add the sidecar. The part which is related to sidecar is marked in green rectangle. So you can notice that the same volume is mounted to example container and also to sidecar container, and tail is uh, running to read logs. Okay, but using this trick, you must be careful. You should use option F, written as capital letter, because this option tells tail to track changes in the file just by name instead of checking IO nodes, which changes during quotation. Also, when you use option F written as capital letters, tail will uh, try to open the file when the file is not present. So you need to be careful using tail in the sidecar container. And as I said earlier, when you use the sidecar containers, log will be available on standard output. So you can get these logs using kubectl logs command, and logs will be also available in standard localization. So it's really nice trick. But of course, I prepare something better. So here, the concept is similar to the concept which I proposed in the previous trick, but this time in the sidecar container, tail is not used to read logs, but there is specialized logging agent which has configuration for reading logs. In this example, it is a tailing sidecar. I will say a couple of words a little bit later about this image. And generally, idea is exactly the same as previously. So there is volume, which joins to containers, application container, and sidecar container, and log file is saved on the volume. Okay. And tailing sidecar, which is running in sidecar container, bases on FluentBit with configuration to read logs and redirect them to standard output. And it has in configuration also database to save the status of reading. And there is also slightly modified out pstdout plugin which prints the records and redirects them to standard output. Code of this container image can be found on the GitHub. This image is also available in GitHub container registry, and there is this image can be configured in simple way just by using environmental variable which must be set to the path to the file with logs that we want to have on standard output. And here also you can see example sidecar that can be added to the pod to redirect logs from the file to standard output. And you can notice that there is an environmental variable set to the path to the log file, and there is also the same volume mounted to both containers. And there is one more volume on which database in which status of reading the log file is saved. Okay. And of course, when you use this specialized image inside the container, logs are again available on standard output and can be get using kubectl logs command, and logs will be also available in standard localization. So it is really nice trick. And it can be used in production clusters, but I think that DevOps engineers like when things are done automatically by magic tools. And there is magic tool that can add tailing sidecar container to the pod automatically. So the good information that there is tailing sidecar operator, and it can automatically add tailing sidecar container to the pod. And I think that configuration for this operator is easy because all what you need to do to use this operator is mentioned on this single slide. So you need to add Helm repository and then install Helm chart in your cluster and add simple annotation to the pod, which will contain configuration for tailing sidecar operator. And in the minimal form of the annotation, you should provide only the volume name and path to the log file, and that's it. Even sidecar container name can be generated by operator, and that's it. And if I must, I could finish presentation now, and I will be sure that you will be able to use this operator without my help. So I think that this configuration is really easy. But thankfully I have more time and I can tell you more about this operator and explain how it works. Okay, so you know this picture. This is exactly the same picture as I showed you in fourth trick. So it is what tailing sidecar does. It does add tailing sidecar container with specialized image, adds the volume to this sidecar container, and log file must be saved on the volume just to make this file accessible for sidecar container image. I mentioned the fact that tailing sidecar operator can add container to the pod. And some of you could think that I said something wrongly, because in reality, container cannot be added to existing pod in Kubernetes cluster. Only few parameters can be changed in specification of existing pod, and it's not the whole container. So when you try to add container to existing pod, you will see a message similar to the message which is visible on the slide. Of course, we can use kubectl apply with first option, but it will just delete the pod from the cluster and create the pod once again. And it's not what we would like to do. So the question is if we can do it smarter. And thankfully, we can. We can do it smarter, and it can be done by leveraging advantages of special admission controller, which is mutating admission webhook. Generally, admission controller is a piece of code that intercepts requests to the Kubernetes API server prior to persistence of the object, but after the object is authenticated and authorized. Usually, most of the controllers are compiled into kube API binary and may be configured only by cluster administrator. But there are two special controllers that can be configured in Kubernetes API, and it is mutating admission webhook and validation admission webhook. You can see blocks for these webhooks on the diagram. It is in third block and fifth block. Admission controllers may be validating, mutating, or both. Mutating controllers may modify related objects to the request they admit. Validating controllers may not. Simply saying, mutating webhook can modify object before this object is created in the cluster, but validating webhook extends validating methods for objects specification. So for example, you can implement validating webhook that will check container image if in configuration of the pod. And for example, validation webhook could reject creation of the pod which uses a container image from not allowed container registry. Tailing sidecar operator uses mutating admission webhook, and when this operator receives information about the request for creating pod, and there is configuration for this pod to add the sidecar container to this pod, then tailing sidecar operator modifies specification of this pod before this pod is created in the cluster. I must mention that update operation is more difficult because when you remove the configuration for tailing sidecar operator, this operation is related to removing container from existing pod. Uh, so that when you would like to make such changes, you will need to again use kubectl apply with force option just to edit this pod. Okay, we can move further. And when tailing sector operator intercepts requests about creation or update, it compares the existing specification of the pod with desired state, and operator makes necessary changes in specification of the pod, and pod is created with proper specification. When you would like to use admission webhook in your cluster, you will need to check if webhook controllers are enabled in the cluster. Then you will need to implement HTTP server. This server is implemented in tailing sidecar operator, and when you deploy tailing sidecar operator in your cluster, you deploy also this HTTP server. And to use admission webhook, you will need to create mutating webhook configuration in the API. This mutating webhook configuration is created when you install tailing sidecar operator with Helm. Okay. And here you can see example specification of mutating webhook configuration. You can notice that under client config, there is a section with configuration of the service, which is used to communicate with webhook. And there is one more important section, which is section rules. And rules describes what operation and what resources the webhook cares about. And here you can see that this webhook cares about operations create, update, delete for any pod in the cluster. Okay, as many operators, tailing sidecar operator extends Kubernetes API and introduces a custom resource definition to specify new object, which is tailing sidecar config. And as you can expect, this new object allows to specify configuration for tailing sidecar operator. This is the second method for providing configuration for this operator. The first is configuration in annotation added to the pod. The second is the configuration provided in tailing sidecar config. The configuration in tailing sidecar config allows to use more advanced configuration options. For example, it is possible to use selectors to make the same changes in the group of pods. So there is no need to add annotation to each of these pods. Okay. Here you can see example configuration for tailing sidecar operator. On the left, you can see tailing sidecar config, and you can notice that tail volume must be configured. So there is volume mount, there is name of the volume, and also path, mount path configured for this pod. And also path to the log file is provided and must be provided. as I mentioned earlier, it is possible to use uh, pod selectors. Here you can see that it uses match label selector and it matches tailing sidecar label. And the same label is configured in the pod specification. Uh, and I must mention that that volume mount, which is used in tailing sidecar config, supports all options which can be configured for volume mount in Kubernetes API. So you can use this exactly in the same way. And also match label selector uses all options which are possible to use in Kubernetes API. So you can use either match labels or match expressions just in the standard way. Okay, so this is the time to see changes that are made by tailing sidecar operator after applying the configuration from the previous slide. So the sidecar container is marked in green rectangle, so you can see all the changes. And you can notice that this sidecar container uses a specialized container image for tailing logs, which is tailing sidecar. Also, there is environmental variable with configuration to the path to the log file. And there is one more variable which indicates that this is a sidecar container added by tailing sidecar. And that's it. Uh, I when you see that this kind of changes are added, you'll be sure that logs will be available on standard output and will be also available in standard localization. So you can read these logs using a standard pipeline for getting logs from all pods in Kubernetes cluster and storing them in one place because logs are available in varlog containers and in varlog pods directory. So I think that it's wonderful that we can do it using tailing sidecar operator. And this is the end of my presentation. I hope that you enjoyed and you learned something that can be useful for you or inspire you to make some changes in your Kubernetes cluster, either by using a tailing sidecar operator or writing your own operator and leveraging advantages of mutating webhooks. So thank you, and now we have some time for your questions.
Thank you. That was very insightful. So thank you. And big shout out. Actually, this was her first time doing one of these presentations. I think she's done a phenomenal job. So if you guys do have any questions, now would be the time to post them. We'll give you a minute or two. Kind of I think it's a little bit shorter than we usually do, but that allows a lot of time for feedback. And I quite like that, right? It's quite nice when you're actually able to get targeted responses. So
Yeah.
so we'll just give that a minute to see if anything comes through. For those that aren't aware, there is a tab specifically for questions and answers, so you can just click Q&A and then post anything you have there. Um, just a reminder that after this, we will be heading to a lunch break as well. So yeah, basically use these wise people while they're here because they're going to be going for a little bit of a nibble, a little bit of lunch in a second. Hmm, I don't see anything coming through. I guess you were just, you were just too smooth. Like you kind of covered everything that maybe everyone had in mind, which is a skill in itself. So well done on that. But I think if there aren't any questions that are going to be coming through, then maybe we'll round this up and lead into an early lunch. So is there any rounding thoughts you want to add? Anything that maybe you didn't get a chance to squeeze in halfway through that you thought of at the end here?
Oh, I don't have anything in my mind.
Okay. Well, that's absolutely. Oh, well, you got plenty in your mind. You shoot that. You're a intelligent person. It was actually a pleasure to listen to you. Thank you for giving us those insights. But that does mean we're going to be heading to a lunch break now, which means you've got a little bit of snack time. It's going to be an hour until, well, a little bit of an hour until the next speaker is available, and that is going to be support or not to support. That's the question. The question that we'll be posing to Ray Bogman. So be sure to tune in for that in about an hour and 15 minutes. But thank you for your time, and hopefully we will see you again very soon.